An honest use of materials means that materials are chosen for their natural properties, not forced to serve some function for which they are not suited. All arches over doors and windows were formed with flexible bamboo rather than rigid lumber cut and pieced together. The bamboo, when curved and tied together with wire, becomes very strong. Partial bales of straw were then used as filler on top of the bamboo. The arch is covered in wire mesh in preparation for mudding. Cob, which is loose straw with enough mud added to make it stick together, was used to blend the arch naturally into the wall. Expanded metal lath is added around all windows and doors. It is affixed to the bales with landscape staples. And all the adobe walls will have wire netting nailed into place as well. This serves as both structural reinforcement and to help the mud plaster adhere to the adobe wall. Passive design measures, such as paying attention to which way the windows face in relation to the sun, will add little or no expense to the construction cost of the building, but will substantially reduce long-term heating and cooling costs.
That looks really good. Let's check it this way. Looks great.
The windows themselves are double-paned, argon-gas filled, and have a low E coating that aids in reflecting heat back inside during the winter months and keeps heat outside during the summer. This part of New Mexico is 5,000 feet above sea level, so the argon gas between the panes will soon leak out due to the low air pressure, and consequently will not contribute to the insulation value of the windows. It is often recommended that low E coating not be used for south-facing windows, in order to let more heat energy into the home in winter. For this house, however, it was decided that keeping the summer heat out was more important than a slight decrease in winter heat gain, since the house has no mechanical air conditioning system. Therefore, low E glass was used on the south-facing windows.
Corrugated cardboard baffles were used to reduce the size of the gap between the outside roof sheeting and the interior ceiling. This saved money in that we only need a 15-inch deep space here for blowing in the insulation to R55. The baffles also prevent the insulation from sliding down the steep pitch of the roof to the lowest part of the roof. With the corrugated cardboard baffles in place, the insulation can be blown in to fill the entire remaining space at a constant depth. Sheetrock was then screwed to the roof trusses. After working with very pliable materials like mud and straw bale, sheetrock was a real letdown. It's a rigid material that requires precise installation. An adobe wall with slight curves and waves looks really beautiful, but a sheetrock wall or ceiling with waves in it just looks like poor craftsmanship. Initially, some sheetrock panels were temporarily left out at the top of the ceiling so that there would be access for blowing in insulation.
Blown-in cellulose will be used to insulate the ceiling. Equipment for blowing in cellulose can be rented from a local home supply center. Cellulose insulation is made from recycled newspapers with a small amount of boric acid added to make it flame and insect resistant. It will be applied to a thickness that will give the roof an R55 rating, even though code in this part of the state only requires insulating to R30. Since it is being blown in dry, the insulation will eventually settle to around R50. One advantage with blown-in insulation is that it fills in all the cracks and gaps that often remain when typical batt insulation is used.
With the insulation in place, The seams of the sheetrock are taped and mudded, and the screw holes are filled. The term mud, when used with sheetrock, refers to a plaster-like substance and not the earthen mud we're using in the rest of the house. Again, this is a procedure that takes some care in order to get invisible joints. 3 coats of sheetrock mud were applied and then lightly sanded. While we work on the inside of the house, the well drilling company arrives and gets to work on drilling the well for drinking water.
All homes in the village of Corrales use individual wells for drinking water and on-site septic systems for sewage treatment, since neither a central sewer system nor water system exists here. It uses a 1,000-watt, 120-volt submersible pump that runs off the AC side of the photovoltaic system.
This is our pump, Fairbanks Morse. This is a half-horsepower single-phase motor. The lower part is the motor assembly, and the upper part here is the pump. We have attached a 1-inch plastic pipe to the pump, as you can see here. We've attached a polypropylene rope to the pump, and we'll be using the rope to lower the pump down into the well once we start that part of the operation. The suction level of the pump will be about 20 feet below the last measured water level. In this case, about 50 feet below ground level, so the suction level of the pump then will be about 20 feet below that. The overall well depth is about 280 feet. It's a fairly heavy unit, weighs 30-some odd pounds. In order to get good control over the dropping of the pump down into the well housing, we've stacked up some straw bales here and put a seal pipe across the top. And what we will do is we'll take the polypropylene rope which is attached to the pump, and we will make a couple of turns around this steel pipe so that we'll have very good control over the descent of the pump down into the well housing. Okay, I think we got it in place. Okay. We're now ready to put the cover plate on. And this will make a weather-tight seal with the electrical junction box. We've assured there's an adequate amount of water in the well. We're going to check the clarity of the water now. It's pretty clear. The pump is drawing about 9 amps, and we're pumping about 11 gallons per minute.
With the mud plaster workshop quickly approaching, there is a final push to complete all the wall detailing. A 2-foot-high band of conventional cement stucco is used for the bottom of the exterior walls. This is an area where mud plaster alone can be damaged by rain splashback or even by watering the garden. The 3-coat cement stucco makes for a durable zone of protection and also adds visual interest to the building.
2 coats will be applied before the mud plaster workshop. The 3rd coat of stucco, which will be a color coat, will be applied before the finished coat of mud plaster. A couple of inches of cement mortar was laid atop the straw bales below our south-facing windows. This will be the base for the flagstone window seats. We used cement mortar when the flagstone would be sat upon or was going to take any significant weight. Otherwise, we just used cob and mud as a base for the stone. The window seats are a free bonus in straw bale construction due to the thickness of the walls. They look great, and they're also functional in that it gives additional places to sit, which is always welcome in a small house.
An important goal in designing this home was to demonstrate how various elements of a building can work together harmoniously, as opposed to being separate components which were simply assembled under one roof. On a sunny day, the roof becomes part of the electrical system, and on a rainy day it collects rainwater for the cistern. And by letting in just the right amount of sunlight, the windows can work in conjunction with the floor and the walls to keep the inside of the house comfortable at any time of the year.